can be reduced and it can oscillate between two different forms, an oxidized form and a reduced form. And it can pick up electrons or it can donate electrons. We think of NADH as kind of a shuttler of electrons, in fact. So let's see what happens. What NADH plus does is it can pick up 2 electrons and a proton. And when it does, it becomes NADH. It can be reduced to NADH. It can pick up or gain electrons to NADH. And so it can carry around high energy electrons. That's really the beauty of NAD plus and NADH. This molecule is sort of like a big truck. That's why I have this guy, okay? This molecule you can think of as a pickup truck or as a dump truck or something like this. NAD plus is a molecule that has the ability to pick up high energy electrons, to be reduced, to gain high energy electrons. And it picks up high energy electrons from glyceraldehyde 3-phosphate in this reaction. Think of these little tennis balls as the high energy electrons. And as it does, it then becomes NADH. Now it's filled up. Its dump truck is filled up with high energy electrons. And we can think of NADH as being a little shuttler of high energy electrons. It's going to carry these high energy electrons around and maybe use them for good later, use them to help make ATP later. So NAD plus can grab high energy electrons. In this reaction it does. It picks them up from our sugar, well, what used to be our sugar, right? Our food. Picks up those high energy electrons and now has made something called NADH. This is a shuttler of high energy electrons. It's great. We've just made an important product that's going to be used later to help make ATP. So we're going to shuttle these high energy electrons around and we're going to use them to make ATP later. Right? So some of the energy in our sugar that we started with has now been kind of tapped into and we've made NADH. The enzyme for making this is called a dehydrogenase enzyme. The enzyme is a dehydrogenase enzyme. This one is called something like triose phosphate dehydrogenase, but whenever you see a dehydrogenase enzyme, you start thinking, this is a redox reaction. In this reaction, or dehydrogenase reaction, enzymes catalyze the removal and transfer of hydrogens and their electrons. So we see the removal and transfer of hydrogens and the protons and their electrons to NAD plus in this reaction. So the enzyme here is a dehydrogenase. Whenever you see redox reactions, think, I bet a dehydrogenase is involved here. And this reaction is exergonic. This reaction is energy releasing. That's what that means. What happens in this reaction is these high energy electrons move to a slightly more stable space in NAD+. They fall to a more stable space. That's energy releasing. And guess what the energy is used to pick up? The energy is used by this molecule to pick up an inorganic phosphate. So energy used to pick up a phosphate molecule, okay? And now we have a molecule that's no longer a sugar. It's called 1,3-bisphosphoglycerate. It has 2 phosphates on it, and those must be useful for something. And this step happens twice. So remember, we have 2 molecules of glyceraldehyde 3-phosphate that can go through steps 6, 7, 8, 9, and 10 if we started with 1 molecule of glucose way back there. Okay, I think we're ready to take a look at what happens in step 7. But this was a huge step. Our first redox reaction, our introduction to our shuttler of high energy electrons. And now we have a molecule that is ready for action. We're going to see what happens to these phosphates in steps 7 through 10.